Hey kids, welcome to lesson 7.4, ArrayList Algorithms. Kids, this is going to be a pretty short video here today. Most of what you're going to be doing is practicing what we've already done. There are really a couple standard algorithms we're going to use. You've seen most of these. And what you're going to do is, through these next couple of lessons, put this into some practical use. What are these standard elements? Well, inserting elements, deleting elements, determining the minimum or maximum value, computing a sum, average, or mode of elements, searching for a particular element in an array, determine if at least one element has a particular property, determine if all elements have a particular property, access all consecutive pairs of elements, determine the presence or absence of duplicate elements, determine the number of elements meeting specific criteria, shift or rotate elements left or right, and reverse the order of elements. Kids, on the AP exam, this is what you're going to need to know how to do. At a minimum, you're going to have to apply this knowledge somehow. And this lesson is all about practicing that knowledge. We have two common ArrayList traversal loops that can be used for these algorithms. We have our enhanced loop here, kids, and we have our standard for loop here. Again, remember, for adding or removing, we got to go with our standard loop. Anything else, we can use our enhanced for loop. Let's do some practice, kids. What will print when the following code executes? We have a array list integer. It's called numList. We're adding 1, we're adding 2, we're adding 3. We are setting 2 to 4, 0, 1, 2. So that becomes 1, 2, 4. We're adding a new 1 at 5 at position 1, 0, 1. That means we go 1, 5, 2, 4, and then we're adding a new integer 6. 1, 2, 5, 4, 6. 1, 5, 2, 4, 6. 1, 5, 2, 4, 6. Because 5 is going to index 1. I think this one's it, kids, unless I confuse myself. Hey, there we go. What will print when the following code executes? We have a list integer called list1. We're adding 1. We're adding 2. We're adding 3. And then we're removing at index 1, 0, 1. Then we're printing the list. We should get 1, 3. 1, 3 is D. The following code is supposed to initialize the array to 0, 1, 2, 3, 4, and then remove every other element to get 1 and 3. However, when you remove an element, the size of the array changes and elements move up on the index. See if you can figure out why you get an unexpected result. Try the code lens if you need it. I think we can do it, kids. We have our public class array list. Here we have our array list, which is an integer. It's called arr. We are going to progress up to it until we are less than 5. So that means 0, 1, 2, 3, 4. And we're going to add whatever index we're at. So we're just printing them off. Then within the index, we are going to mod it by 2. And if it equals 0, well, then we're going to remove that element. And since this is a nested loop, I know we only have 2 print statements here, but we're going to get 3 because it's going to go for the first, the second, and the third. And the issue here, kids, is we should remove the first, the second, and the fourth because we're removing every other element. But if we're changing sizes, kids, that's not going to happen. We'll remove the first one, so we should get something down here that says removing element 0 at 0. But then when we go up, kids, 0 is removed, and we're going to start off at 1. That means we're going to go to the second spot there and remove 3. That means it will print 0, 0, and then removing the element 2, 3. That means our print should probably be every other number 1, 2, 4 though, even though it should be 1, 3. That's because the list is decreasing as we go through, so the indexes change. Woo! Let's see if I'm right, kids. There you go. We removed 0, 0. We started off at 1, and then 1 became the first position, and then we skipped the element because, again, we are inside the loop. So instead of getting 1, 3, we get 1, 2, 4, kids, just because our loop keeps decreasing as we go down. We have a note here that kind of explains that. If you add or remove inside a loop that traverses an array list, you may get an unexpected result because the size of the array list has changed. So again, kids, if you're nesting loops, be very careful if you're adding or removing because it's going to change as we do it. Some algorithms require multiple string array or array list objects to be traversed simultaneously. For example, the following code traverses 2 parallel array lists that hold the grades for different tests. Ooh, that sounds fun, kids. And you see we have our public class parallel tests. We have 2 array lists, both integers, test 1 grades, test 2 grades. Test 1 grades, we're adding 100. Test 2, we're adding another 100. Test 1, we're adding 80. Test 2, we're adding 70. Test 1, we're adding 70. Test 2, we're adding 90. And then we're creating a new variable total, which is a double, setting it equal to 0. We're going to go through the list, and we're going to add grade 1 to grade 2 at that index. That means we're going to get 100 plus 100 and add them up. Then we are going to create another integer called number of grades, and that's going to equal the test 1 grade size. But since we're taking an average here, kids, we're going to double that by multiplying it times 2. Then we're going to print off average over 2 tests is the total here divided by the number of grades here. So we're adding up all of these here. We're taking the number 1 test grades times 2. So if we add these up to, off the top of my head, I think that's like 5, 10 kids. We have 1, 2, 3. We're going to divide that by 6 because we're taking 3 times 2. So 5, 10 divided by 6. I think that should give us 85 kids. Let's go ahead and hit run and see if I'm right. Hey, there we are. So these are 2 loops doing 2 different things, and we can still bring them together to use them. Pretty neat, kids. For this last part, we are actually not going to cover this in this video. Most likely, kids, I'm going to assign different groups different questions here, and you're going to have to work them out and make some videos. And hopefully those videos are what I'm going to post here. Most of these have video solutions to them already, and the ones that do not have the answers right below them. So there's really nothing for me to cover here, kids. But with your help, we're going to make a nice little library on how to solve these free response questions. But for this video, that's all we're going to cover. Hopefully this helped you set up for the practice algorithms you're going to do in this lesson. As always, if you have any questions, kids, come see me. Otherwise, I'll see you in the next lesson. See you later, kids. Bye. Bye.